In today's lesson, we're going to look at the side lengths of triangles and learn how we can use the side lengths to determine if a triangle is indeed a triangle. But before we get to all that, we're going to look at one of the triangles that you worked on yesterday that was a little more thought-provoking and see if we can't figure out the missing angle measure together. All right, so let's look at what we know in this problem to start with. So we know that in triangle ABC, and let's look at triangle ABC. That is ABC. So that's the big triangle in blue. In triangle ABC, the measure of BAC is 42 degrees. So angle A is going to be 42 degrees, and they show us that. So we see that, okay? So the main measure of angle BAC is 42 degrees. And angle ABC, so angle B, is 90 degrees. And that's also given with that little angle in the corner. And the other thing it tells us is that line segment BC is equal to line segment BD. So I like to just highlight this so we can see line segment BC. Let's see here. BC is equivalent to BD. And we have those single tick marks to show us that those two side lengths are equal. Our task is to find the measure of angle CBD. So CBD. Okay, so we're going to be finding the measure of angle CBD. So that angle right in there. All right, so to solve this, let's start with looking at the larger triangle. And the reason why I want to look at that larger triangle, I'm going to trace it again in blue for us. The triangle ABC, okay, this highlighted blue. The big triangle is because I have two of the angle measures in that bigger triangle. I know that this measure in the bigger triangle is 42 degrees, and I know that angle B in the big triangle is 90 degrees. And I know that the total measure of three angles has to be 180 degrees. So one of those angles is 90 degrees and the other is 42. So I can pretty easily find that missing angle. So if I add 90 plus 42, I get 132. So that's this plus this is 132. So to find this missing space, I simply need to subtract 132 from 180. And that missing angle is 48 degrees. So I know that this missing angle of the big triangle is 48 degrees. Now, just to double check myself, again, remembering that I'm looking at this larger triangle, the large blue one, let's add those three angles together to make sure they equal 180. So 42 plus 90 plus 48. So 8 plus 2 is 10. 4 plus 9 is 13, plus 1 is 14, plus 4 is 18. So yeah, that's 180 degrees. All right, so now let's look at the next piece that we know. And I'm going to see if I can clean this up a little bit so we can look. Okay, just so we can kind of see what's underneath it here. All right, so now that I know the large triangle, the other thing I see that I know is that because this is an isosceles triangle, right, the smaller guy, so I'm going to look now at this green. I'm going to highlight in green. Now we're going to be looking at the smaller green triangle that's within that larger one. And I see that it's isosceles because it told me that this side length and this side length are of equal length. And I remember that when I have an isosceles triangle, the angles opposite the equal sides have to be equivalent as well. So because this angle is 48 degrees, that tells me that this angle has to be 48 degrees. So now that I know two of the angles of the three angles in this triangle, I can figure out that missing angle. So I know one of the angles is 48 degrees. I know the other angle is 48 degrees. And this angle that we originally highlighted in red right here, this is the angle we're looking for. That's our question mark. Now some of you might have thought, well, Mrs. Perkins, that has a right angle right there, so it's a right angle. But if you look, there's a little sliver of it missing that goes to this other triangle over here. So we have to figure out what is that angle B with that sliver missing. All right, so let's figure it out. If we figure out this combined amount, so 48 plus 48 gives us 8 plus 8 is 16, 4 plus 4 is 8, plus 1 is 9. So I know this is 96. So to figure out the missing part, 180 minus 96 would be 84 degrees. So this missing angle is 84 degrees. So yesterday we really talked about rules of triangles and how using what we know about right angles, isosceles triangles, and equilateral triangles, we could figure out angle measures. Well, today we're going to look at the side lengths of triangles to help us figure out if those side lengths could actually form a triangle. Okay, so the rule states this. It says the sum of the lengths of two sides of a triangle. So any two sides, the sum of those two lengths has to be greater than the length of the third side. So for example, in this triangle, side AB is 7 centimeters, and let me erase this, and side BC is 5 centimeters. Okay, so 7 centimeters plus 5 centimeters is, we're looking at this chart over here, by the way. It correlates to this thinking right here. So 7 centimeters plus 5 centimeters is 12 centimeters, and 12 centimeters is greater than 4. So AB plus AC is, or sorry, BC is greater than AC. So that is a check, okay? That holds true. That follows the rule of the triangle sides. Let's look at two other sides, okay? We'll look at this one next. So if we look at AC, which is 4 centimeters, plus AB, which is 7 centimeters, well, 7 plus 4 is 11, and 11 is greater than 5. So those sides check out, okay? Those follow the rule of the length of the sides. And the last one let's look at is side AC, so 4 centimeters, plus BC, 5 centimeters. Well, 4 plus 5 is 9, and 9 is greater than that third side, which is 7 centimeters, so that checks out. So we can have a triangle that has the side lengths of 4 centimeters, 7 centimeters, 5 centimeters. This does form a triangle. All right, so if we had a triangle and we were given these side lengths, 5 centimeters, 6 centimeters, 7 centimeters, let's figure out if this could actually form a triangle. And the way to find that out is to add two of the side lengths together and make sure that those two side lengths are greater than the third side length. Then check the same thing with the other two side lengths, and then check again with the third set of side lengths. So watch. First, let's try adding 5 plus 6. So if we have 5 plus 6, that gives us 11. Is 11 greater than that third side length, 7 centimeters? Yes, it is. So we're good with those two side lengths. Next, let's check 6 plus 7. Okay, so we have 6 plus 7. We know that is 13. And the third side length then is 5 centimeters. So is 13 greater than 5? Yes, it is. So those two side lengths check out. And the last side lengths that need to be checked are 7 centimeters and 5 centimeters. So 5 plus 7 is 12. And the third side length is 6 centimeters. And 12 is greater than 6 centimeters. So that side length checks out. So we could have a triangle with the side lengths of 5 centimeters, 6 centimeters, 7 centimeters. It is possible to make that triangle. And here it is, the triangle with 5 centimeters, 6 centimeters, 7 centimeters. The sum of the lengths of two sides is greater than the length of the third side each time, checking each pair of sides. Let's check another one. What if we had a triangle with the side lengths of 2 inches, 4 inches, 1 inch? Could this form a triangle? Well, let's check by looking or combining side lengths. Let's first look at adding, 2 inches plus 4 inches. So 2 plus 4 is 6, and 6 is greater than that third side length of 1 inch, so that side checks out. Next, let's check 4 inches plus 1 inch. So 4 plus 1 equals 5. And is 5 greater than that third side length of 2 inches? Yes. So that side length checks out. The last one we need to check is 1 inch plus 3 inch. So 1 plus 2 equals 3. My brain was thinking ahead. Is 3 greater than that third side length, 4 inches? No, it is not. So we cannot have a triangle with side lengths of 2 inches, 4 inches, and 1 inches. That would not form a triangle. And here is what that triangle would look like with a side length of 2 inches, 4 inches, and 1 inch. Do you see how it wouldn't connect because one of the side lengths would be too short? So the other two sides would not be able to meet. Okay, your turn. Will you check to see if these three side lengths could form a triangle? The triangle would have side lengths of 10 inches, 13 inches, and 4 inches. Check each of the side lengths to see if it's possible for this to form a triangle. Pause the video and check back to see if your thinking matches mine. So now that we know this rule about side lengths and triangles, let's try something a little more challenging. So this talks about finding the possible lengths of a side of a triangle given the lengths of the other two sides. So the information we're given is that AB is 11 centimeters. So in a triangle, AB would be 11 centimeters. BC is 14 centimeters, and we don't know the exact side length of AC, but we do know that AC is going to be greater than 20 centimeters. So we need to find, our task is to find the possible lengths of AC in whole centimeters. Okay, so some of you might be already jumping in and thinking about this. I'm a visual person, so it helps to see, or it helps me to see, even if it's not drawn to scale, just to see the triangle with the side lengths that we do know plotted out. Well, because we know that two lengths, when added together, have to be greater than the third side length, let's add the two sides that we do know together. 11 plus 14 would be 25 centimeters. So 25 has to be greater than the third side length, which would be AC. And the only information we were given is that AC has to be greater than 20 centimeters. So what numbers are greater than 20 but would be less than 25? Well, 21, right? So AC could have a side length of 21 because that would still allow 25 to be greater than 21, 22, 23, and 24. So these side lengths would all follow that rule of two side lengths, their combined sum has to be greater than the third side length. So those four options would work. Now, just to check, let's take each of these and let's combine them just to see. So now if we added BC plus AC, so if we had 14 plus 21, is that going to be bigger than the third side, which would be 11 centimeters? Yes, all of those would be, because we have a side length in the 20s, and that's already bigger than that third side length of 11 centimeters. So that would work. And what if we added 21 plus, what if we checked now AC plus AB? So it would be, our guess would be 21 plus 11. Is that going to be greater than 14? Yes, again, because we have a side length in the 20s, which is already greater than that third side length. So those would be the four options that would work. A side length of 21, 22, 23, or 24 centimeters. So in today's lesson, we learned that the sum of the lengths of any two sides in a triangle has to be greater than the length of the third side. This is a rule for triangles and how they can be formed.